Okay, this is a companion piece to something you're going to do a lot of, which is learning to offset a line through the origin. Remember, you do that by calculating the slope-intercept of the line and then multiplying that slope-intercept by the cosine of the angle that defines the line from that famous equation y equals tangent of theta x plus b, not y equals mx plus b. Of course, you know that the slope is in fact the tangent of the line. You also know that the slope of the perpendicular is the negative reciprocal, 1 over the slope with a negative in front of it, or 90 degrees plus or added to or subtracted from the direction. But now let's look at the other way. Let's say if you wanted to in fact take a line here, and I'm going to just take an arbitrary line, I'm going to move this up, and you wanted to actually take that line and in fact offset a distance of 5 and give you what is the equation of that next line. How are you going to do that? Well, what you're going to do is you're going to take to get the shift in the slope-intercept, because you know it's going to be the same slope, you're just going to take the 5 and divide by the cosine of the direction. So let's see what that looks like. So we're going to say here list this line, and it has a direction of 73.794. Alright, so I'm just going to take this right here, and we probably lost our calculator. We did. Bring it back if we can here. Run it again. I lost my calculator, so I'm going to have to go ahead and rerun my calculator. And that's in fact why you might want to learn to have that unit circle so you can get a lot of this guesswork done as you try to really establish what you're doing here. What you're trying to figure here is this, that in fact you are file new, right? That you've got one equation but it's got two manifestations. So we said here we're going to take 5, right? I'm going to hit clear. We're going to turn the mode on, double check that it's degrees. A couple other things over time you want to do. You're going to take 5 and divide it by the cosine of about 70, turned out to be about 74 degrees. And that's going to tell you what the change in your slope-intercept would be. Well, let's look. Now let's just offset, wrong program, it's 18. We're going to offset this 5. And then trim, fillet, holding the shift key, click, click, undo. What you're going to want to do is I'll just trim. Screw that, click, click, and that offset of 5 led to a shift in the y-intercept of around 18. There you have it. So that wasn't, I didn't plug all the numbers in exact, but you just got to get that inference that you are dealing with the cosine of the direction angle, and it's because of the phase shift of 90 degrees if you really look deep into this. But this is one of these now learn Rote. Go back to the right. You realize the cosine is involved along with the tangent when you're trying to offset lines. A really key thing for figuring out the swipe distance of a force about some 0 point that you move around your drawing so you can do this easy calculation of torque. It's great also, just you have to realize this is just an offset problem. These are called vector projections, if you would, for doing offset problems in the field. Thanks for listening.